Assalamu alaikum. Hello guys, how are you? I hope that you all are fine. Today in this video, I will show you how to determine the fundamental period of vibration of a building structure. Why we need fundamental period of vibration? Okay, we need fundamental period of vibration to perform equivalent static analysis of for earthquake load analysis. Okay, for earthquake load determination. That is why we need fundamental period of vibration in x and y direction. So what is fundamental period of vibration of a building? The fundamental period of vibration of a building is uh, the mode in which the whole building will oscillate in one loop hither and thither. Okay, you see, let us consider this cantilever beam. You see it is fixed at the base and its main position is this, and when earthquake base shear will excite this building laterally at the base, then it will oscillate in this manner. Okay, so this is the fundamental mode of vibration. You see, if you consider this, you see that there is two loop. One is this and another is this. Okay, if you consider this, there this it is vibrating in three loops, 1 2 3. Okay, so I hope that you have understood what is fundamental mode of vibration. Okay, so fundamental period of vibration of a building is the period of the building in which the building will oscillate hither and thither in one loop. Okay, in the fundamental loop. Let me show you more example. See, it is called one loop, this is called two loop, this is called three loop. Okay, the fundamental frequency is defined as the lowest frequency of a periodic waveform. Okay, so the lowest loop is one loop. If you see this one, you see it is fixed at ground, this tower is fixed at ground. When earthquake load will earthquake base shear will excite the building at the base, then it will oscillate hither and thither about the mean position, about its mean position. Okay, you see this cantilever beam is fixed at the at one end, and another end is free. It is oscillating hither and thither about its mean position in one loop. You see, this is not the fundamental mode of vibration because it is vibrating in two loops. Okay, it is also not the fundamental period of vibration, fundamental mode of vibration, because it is uh, twisting, it is rotating about its own axis. Okay, this is the fundamental period of fundamental mode of vibration because it is um, oscillating up and down uh, about its mean position in one loop. Okay, this is also not the fundamental mode of vibration because it is also um, vibrating in two loop. Okay, so I hope that you have understood this. Let me show you how to determine the exact fundamental period of fundamental mode of vibration of a building structure in ETABS. So let us start that. First, go to define. Okay, then you have to define the mass source. Okay, that is to mass source, to modify show mass source. Okay, it must be seismic weight because we are determining the we would like to determine the fundamental period of fundamental mode of vibration of the building during the earthquake event. Okay, so it is seismic weight. The seismic weight is defined by uh, according to National Building Code of Bangladesh National Building Code. The seismic The seismic weight is defined as the total dead load of a building or a structure, including partition walls and applicable portions of other imposed loads listed below. For live load up to including 3 kN per meter square, a minimum of 25%, that is 60 psf. If the live load is 60 psf, okay, then a 25% of the live load should be included in the seismic weight. Okay, if the live load exceeds 60 psf, then a minimum of 50% of live load should be included in the seismic weight. Okay. If you are watching outside Bangladesh, okay, then the seismic weight is should be defined in your local national building code. Okay, follow your local national building code, not necessarily this one, because it is according to our national building code. So let us go back. According to BNBC, live load 0.25 multiplier add, okay, take in the mass options you must, okay, you must take this one, include lateral mass. If you don't take this, no problem will happen, the same result will be yielded, no problem. But remember that don't take the element self mass, because it will double count the self weight of the structure. In dead load, in ETABS dead load, the self weight is already included in the dead load. Okay, uh, okay, okay. Then you have to define the P delta options. You know that when lateral load uh, when the building will be subjected to lateral load, then it will displace laterally, and also at the same time the vertical load will be acting, so there is a P delta effect on the building. Okay, so you should account for the P delta effects, and it should be the same as the um, seismic weight. Okay, take the iterative based on loads and define this as like the seismic weight, then press OK. Then go to define modal cases. Okay, modal cases. Okay, you have to I have already included it for demonstration purpose. Fundamental, it is in the X direction. I am pressing modify showcase. You should press add new case. Okay, I have given the name fundamental mode X. Okay, and I have selected the option reach. Okay, you should select reach because it will yield better result. Okay, and then select the use preset petal option, tick it. Okay, then add, here add, and select the load pattern as acceleration, and since we would like to determine the fundamental mode, fundamental period in X direction, so select load name in UX. Okay, and other parameters, maximum number of modes. You know that fundamental mode is 1, the loop number is 1, so give uh, give a number 1. Okay, then press OK and press then another load case is fundamental period in the Y direction we would like to find, and please select add new case, and since I have already included it, so I am pressing modify showcase. Then give the name fundamental period Y direction reach. Okay, and load name is in the Y direction, UY direction. Okay, other parameters, maximum number of modes 1 1. Okay, okay, then go to analyze and set load cases to run. Okay, fundamental period, make it run, then run. So then go to display and show tables, if analysis tabs, and press results, click on results and go to model results, model periods and frequencies selected. Okay, you see fundamental period in x direction is 1.253 and frequency is 0.798, and fundamental period in y direction is 1.339 seconds and frequency is 0.747. The other definition of fundamental frequency is the lowest frequency. Okay, the lowest frequency of all the modes is called as also fundamental frequency. Okay, but according to BNBC, the exact the structural dynamics procedure, structural dynamics procedure such as Rayleigh's method or modal eigen analysis using structure. Okay, is we have determined the period, fundamental period of the building in exact method. Okay, that is eigenvalue by eigenvalue analysis. But this exact fundamental period of vibration should not exceed the approximate fundamental period of um, vibration by more than 40%. Okay, so the approximate building period can be determined by T equal to Ct Hn to the power m, where Ct equals to, for concrete moving resisting frame, Ct equals to 0.0466, and the exponent of h, height of the building, m, equal to 0.9. Okay, so I have made a Excel sheet to determine it, to determine for earthquake analysis. Since the height of the building is 98 feet, so I have input 98 feet. You see approximate fundamental period is 0.9913, and the exact fundamental period in the x direction is 1.25 we have found from the analysis, and in the y direction is 1.339. You see the difference between approximate and exact is in the x direction 20%, and in y direction 25%, so it is less than 40%. So the acceptable fundamental period of vibration is T equals to 1.25 and Q equal to 1.339. We should use it to determine the design spectral acceleration. Okay, now if we put, you see this is the response spectrum. Okay, now suppose that our building is located in a site where the SPT value is 7. So based on the SPT value in the, you see that according to BNBC code, the average soil properties in top 30 meters is we have to account for the average soil properties in top 30 meters. Suppose that the average SPT value for top 30 meter is 45, then for 45 the site class is C. Okay, and suppose that our building is located in Dhaka, so input Dhaka. Okay, suppose that our building occupancy category is 2, so 2. Suppose that our building is SRCMF, that is special reinforced, the seismic reinforcing system is special reinforced concrete mortar, SRCMF. Okay, so it is automatically changed. Then for 1.25, okay, for period 1.25 in the y direction, if we put this value in building period here 1.25, okay, then we get design spectral acceleration is 0.0230. Okay, in the, it is for x direction, and if you put the period in the y direction, okay, 1.339, that is building period 1.339, put it 1.339, For 1.339, the design spectral acceleration is 0.0215. So thus you can determine the exact fundamental period of the building. Okay, then using this value you can compare it with the approximate fundamental period. Then the controlling value of fundamental period should be taken, and using this acceptable fundamental period you can determine the design spectral acceleration from the response spectrum function. Okay, now let me show you how the building oscillates. So since if I start this, ETABS will make a sound and my voice will be stopped. So before stopping this video, I would recommend you to please like, share and comment, and don't forget to subscribe to my channel. If you like my videos, please give a like. Okay, and don't forget to comment, and please don't forget to subscribe to my channel. So let us show the animation how it oscillates in x direction.